Recording.
Okay, so today we are here to talk smack about SQS and show how can we do better. Uh, we are going to use Postgres to implement some queues, and well, let's just jump into it without further ado. We'll be implementing a first in, first out queue, also known as FIFO. And to do that, we first need to understand something about time in relation to transactions inside the Postgres database system. So I will run these two queries here. And you can see I'm doing a sleep between two calls to null, which is a current timestamp. And here I'm using another function and doing the same sleep for 5 seconds. So just running this, about 10 seconds it will return. And well, what's different between the two is that the first one, this one, using now, it will use the inside the same transaction. Now will always return the same value. So it will not, it's not the real time, the real clock time. And clock timestamp just ignores this transaction thingy and takes the real time, the real clock, real time. Yeah. So in this case, you can see that now reports 2 times the same time, and clock timestamp is the real time that it was when it got called, right? That's very important to make the FIFO part, the first in, first out part of the queue, because we need the real time when something is inserted on the table. We cannot, otherwise we will have the same timestamp for multiple entries, and that's not ideal, because we can lost the order because of that. So with that in mind, we can move on. Unless you have some questions about this.
No question.
Okay, so here I'm doing let's see, the boilerplate of the queue. I'm creating a status enum for, it's basically the state machine of the message processing. So it has waiting, processing, okay, failed, and I'm adding the timeout feature too. So why is that, right? If some consumer starts processing some message and never updates it later, this message will never get processed again. So we need to do some sort of timeout to get it back into the queue in order for another consumer to do stuff with it. And that's why I'm adding this. Hope it's clear why this needs to exist. And so I have here let's see, the skeleton of a queue. We have the status, no? Right, for what's the current status for that message. We have how many tries this message got, how many consumed tries, let's say, it got. What's the maximum that it can be tried? after that, it's considered a bad message and should be handled manually by someone. Um, this is a helper field for the timeout, for setting the timeout, right? This is the message timeout amount, like how much time it takes to set this message as timed out. And this is the helper field for setting this timeout. It need to know when did it start processing. And then we have this created at, which is the criteria to have the first in first out. We need to know the order of insertion. And this column uses the clock timestamp to fill this value by default. I believe this field is not used. I'm not sure why I'm keeping it here right now. I think I can delete it, but I won't now for the sake of the demo. So that's the skeleton table, right? I'm doing the forbidden thing of doing inheritance in Postgres. And this is the instance of a queue. So I'm creating a table. I'm adding the payload here. So my payload is just a username. And there is a primary key here, which is quite important. I mean, what this gives me in terms of a queue, it gives idempotency. So there is no way two producers can stuff the same message from different producers. And this is guaranteed by my database with this constraint. I think this is very, very big for keeping it sane. You don't need to do a lot of shenanigans on your application. And the forbidden part, which is inheriting on the skeleton table. So all these fields get inherited by the use of this keyword. And I'm creating also a dead letter queue, which is just a view on top of this table. And with these filters, like the status must be of failed or timeout, and the number of tries must exceed the limit. So running that, okay, I can drop it for some reason. Let's hope it's okay. I can drop it.
You're the demo gods.
Yeah.
Screw you up.
Okay. I know why. Just a second. Not represent.
I'll drop.
Let's start doing some cascade bullshit. I don't think type has
I was
cascade.
about to say, I think cascading may be the solution to this problem.
Yeah. Let's
I have
just
a
brute
question
force
though.
the thing.
I have a question. So I noticed in your view that you're asking the ones with the status that things got wrong, and the
Yeah.
tries are greater than or equal to the max tries. Aren't these the ones that we are classifying as an error?
Yeah, that's
Is that on purpose?
true.
Okay.
That's I'm not sure if you're familiar with that ladder queue. It's like I have tried processing this, but we failed so many times that we give up.
No,
There
okay.
is no
I
way
was
we
not
can
familiar with that
process this.
convention. Thank you.
And then what you do, right? In the SQS side of things, you have another queue which is denominated the dead ladder of the original queue.
Oh, that term I already heard. That letter.
Yeah, and then you put this message on the dead ladder for someone to investigate
Okay.
why it not did not work and
Okay, so with
fix it.
Postgres you do it like this. Thank you.
Yeah, that's my idea. You can do another table and other
Okay.
fancy stuff.
Thank
Just
you.
that's just a simple way, I think. And here's the table created. It has all the skeleton columns plus the, let's call it the business, the payload, right? Column. And so the next step is for us to produce something in this queue. I'll be doing this by the means of insert. And not sure if everyone here knows, but you can, at the same time of inserting and updating or deleting, you can return the data that got changed, modified, or inserted. And that's what I'm doing here.
Is that any different than the? I know there's the in2, right? But the
Yeah.
in2 you need to assign to a variable. Like, is that the same thing but just yielding?
I'm not sure. Don't know if there is a difference. Perhaps. I have used, I think, the into on PLSQL, not the GML side of stuff. Not sure if that's true. That's the difference. So I have just inserted these three messages, and they are waiting for some consumer to pick up, and so 0 tries for each of them. Then here we have this is what the consumer would execute to take messages from the queue and do something with it, right? So the key point here is that part, which is a combination of two parameters, let's say. The first part, this is the for update. This means that I want to lock the rows that I'm fetching. So every row that this select returns will be locked by my transaction. And skip locked, as the name implies, will skip locked rows when I'm doing this query. So these two in conjunction let us have the non-blocking selects for the queue. And I could demonstrate this in the terminal if you like. That's quite cool, I think. If not, I can just go on. So another thing here, I'm taking just stuff that's not reached the max tries and is of this status, waiting, failed, or timeout. So processing and OK is ignored because either they are being processed by someone or they are already processed. And if they have more than max tries, they are dead letter.
I didn't pay attention to this part, Jean, but does it have some sort of like history? It does, right? Because you're saving and updating, but I think you lose the past attempts this way, right?
Yeah. I'm not saving history by any means here.
Yeah, but I
We are
think
just storing.
if you just add temporality to that table with a plugin, whatever, that should solve the
Yeah.
thing.
Then you can have, yeah, sure. And another, well, this is the part that guarantees the FIFO, right? The order of insertion. And this is the order that I will take stuff from the queue. And the this is something that will be relevant later, which is
Hmm.
the size of the batch that I'm taking from the queue. It could be 1, 10,
Now I have a
a
question.
1,000.
So you're limiting it to 10.
Yeah,
Does it count the ones that you're skipping because they are locked or not?
The ones are
it does.
skipping.
Not sure I follow your
Yeah,
question.
so my understanding, well, that almost went bad. My understanding is that you're skipping the ones that are already locked, the rows in your select.
Yeah.
Let's suppose that
Mhm.
the first three are locked. Okay?
Mhm.
Those will those three count in the limit or not?
No,
Okay.
it's
That's
per transaction. The lock is, let's say, it's per transaction, and every select must return at most 10 items, right?
Okay.
So it will lock at most 10 items for that
yeah.
transaction. If
Yes.
there is like 500 items locked already, it's okay. It's not this query's concern.
Okay, that makes sense. So it's completely orthogonal.
Yeah,
One thing
it's
is
not.
locking.
Well, I wouldn't say it's orthogonal, but because it's equal, but it is because of the. It's because you're thinking of a you have a predicate, right? And then you're limiting the predicate uh, uh, to be a specific way with the limit, and then the
Yeah.
predicate gets updated on top of the mechanism, which is the by transaction. That's a why the for update locked.
Okay.
Blah, blah.
Okay.
Yeah. Oh, just for completeness, I will try this.
Man, I have two questions, but we're gonna be renting on this, so I'll stay quiet for a while.
So I can, let's see,
Hmm.
select. So I have my selected home here. I can do some query on it and just let me take the username, I believe. Yeah. So is the tricky and cool stuff. I can start a transaction by issuing a begin command. Then I can do this select for the date. So I'm locking all the rows from the table. I can go from another session. And if I try to select username from SPS at home for dates, it will hangs. It does not go on because all the rows are locked until I go on and do a commit here or a rollback. So that's the magic working, right? And if I do the skip locked thing, again, oh, sorry, I did not start the transaction. Begin a new transaction, select for update, And then again, I do this here, skipping locked rows. So it returns instantly, and there is no rows available for query. That's why this works.
This
Cool.
is very useful. Just a
Yeah.
comment here, maybe. But I have a situation, right? That basically, like, imagine you have an event sourcing system, okay, and a hypothetical one. And then you have like all the garbage processing of it, right? And then you have the table on your database that actually does the storage of the events, right? So it has a event string, and then it just vomits stuff on that bucket, and then from that it recomposes. The main problem I had with this library here is that we couldn't achieve some sort of transactionality in the case of failure, right? So, for example, you wanted to aggregate a couple of commands in a batch and to say, okay, it's not the kind of situation where you would say them in a group, they don't make sense or they do, and then we can take a decision because that's fine, right? You can just eliminate the the actual progression of the thing as long as you have this whole set. The problem is when you don't have a set, right? Which is the whole point. Uh, like think of, for example, how do you make a set integrity constraint if you don't know the whole set? If you just have the pieces, you need to make a queue, and then you need to process stuff in a queue, and then if that is violated, then you need to reject. But you don't want to commit your event store, otherwise you have garbage there, right? So that was the main conundrum I went into. So we made a whole queue to solve the solution. It's also in Postgres, but I think the transaction is bad because we basically do serially this.
Yeah.
We process serially, right, the
Yeah.
requests as they come in outside of Postgres. So if they are inside, it doesn't matter. They can be parallel as long as we lock the events table, right? Because the transactions will be there.
Seems to be
But
totally the case.
that that sounds insane, but that's a good solution, I think. I mean, with the tools you have at hand.
Given the situation.
Yeah.
So I will execute this. Okay, the rest is just okay. I'm taking the message from the queue, setting it as processing, and incrementing the tries, setting the start processing at with the clock timestamp, and the update that even though we are not using it, and also returning just because. So I took all three messages from the queue. What I will do here is say that ABC failed because yes, GHY I got a oops, got an OK.
Thankfully, there's no C there.
What?
Thankfully, there's no C there. Just GHI, not GHC.
Yeah. And then we have this piece of code that will set the timeout for message that got taken, let's say, from the queue and did not complete yet, given their respective timeout limits. And this gets the DEF as timeout. So here I do. I don't think I need to do this skip locked here, but I do it anyway. And well, that's well, I don't think there is need for that. Anyway, so two messages returned for the queue, which is the ABC and DEF. If I query this again, we can see now they are at the second try and they are up for processing. So I will fail this one again. And yeah, the timeout already happened. Once again, third try, fail again, and timeout again. So now they are dead ladder, right? They reached the limit. And we can see here, this is the final state of the table. So DF timeouted with three tries. ABC failed with three tries. Maybe I should change this number.
Hmm.
And this one got okay on the first try. And then we can select that ladder, and it shows just the stuff that we need to manually check out later, we as engineers. And this is the stuff you get in the incident report or something like that.
Mhm.
Oh, that's the implementation. It's not that complicated. I have built here basically copy and pasted the Sun page from Amazon, and what are the features from a FIFO. It has exactly once delivery, which we have also. It has strict ordering, which we also have. Now for more stuff like maximum payload size. By the standard, SQS enables you to have 256 kilobytes per message. Postgres can have a very complicated limit in this regard. So if we use a JSON payload for that kill table, it is 1 gigabyte of data on the payload. I mean, it's 1 gigabyte per payload.
And this batch size is crazy low.
And if we do the way I did it, like having separate columns and the normal stuff you have in a RDBMS, it varies a lot, the size of the tuple. So it can have at the minimum you will have I mean, the maximum minimum, let's say, it's 450 columns for the type of text and stuff that consumes a lot of bytes in the tuple, which is a pointer. It's 18 bytes, I think. If we use the smaller fields like int, it can have up to 1,600 columns. So that's quite a big payload. Even big corp can do it with their 1,000 columns tables. And it has unlimited queues, which we all know it's probably not like really unlimited, but well, marketing. And a single database that's like default Postgres, no kind of optimization, partition, any kind of smart thing. You can have this number of queues, which is insane. And you can have per queue, which means per each table, you can have 32 terabytes of data stored, or this number here is this 4 billion something divided by the tuple size, which is related to the number of columns, right? So that's a shit ton of data.
I
The
don't think we
summary.
have hard drive for all this.
And We can do batch operations. I just showed you with 10 messages per 10 messages.
Man, why 10 messages? Like, is that a free tier or something? Like, that's so low.
Not sure. I'm not expert on
It does.
cloud stuff.
Go on, Lems.
My microphone
Times.
got busted. It does sound like a
So,
free tier thing. 10 messages. It does sound like a. That's too. That I agree. That's too low. I agree.
like, the rotation I can understand, right? Like 14 days. But man, 10 messages in a batch? Like, is that a consequence of like something they did while implementing it?
That would be funny.
That would be very funny. Yes.
It
That
would
would be
also be
hilarious.
very
There,
arbitrary because 10 is not really a thing in a binary system.
Yeah,
Yeah.
that's
yeah.
the most Marinho comment ever. Go on, yeah.
So the long polling, which is, well, this you have to do by hand on Postgres, but you can do it. Like you just, hey, you do the select, it returns nothing. Well, you just take some more time to select again. That that's what it does. It's not something big, let's say. And well, you are querying your database, so that's probably not an issue for you. That's more for the AWS. Um, Retention is up to you. Sharing databases is up to you. Encryption is up to you. Having a dead letter queue, I showed you, you can have it. And priority queues, as far as I understand, and I might be wrong because I'm not a cloud expert, you have the solution proposed by AWS is, hey, create multiple queues and consume in order for your priority. If the QA has higher priority, always consume from it first. And in this implementation, you can easily just add a column here for priority and do it in the sort, like priority, and then create that. So that's priority for you. You don't need anything more queues or stuff like that. And this is where I got this data from, in case you want to check out. And then there is a new part for this presentation, which is I never go with anyone so far, which is I did a benchmark on this stuff for my amusement. Um, let's start by creating this thing. So I'm creating this tickets table, which is a queue, and it's that ladder. I don't need to truncate it, but I will. And so I'm not sure everyone here is familiar with PG Bench. It is a binary distributed with the Postgres installation. It is used to do benchmarks for Postgres. So that's quite easy to use and very handful for the curious like me. So I'm so this is the command for to do the benchmark. I'm using this is like to run a single command, a single script, not a command, a single script, which is this one. And this script is here. I'm receiving a random number multiplied by the scale, okay? And then I just do a insert and ignore if there is already this number in the table. Okay, so far?
Okay, so far.
Then I will run this. It's this. Okay, it run, give me a lot of outputs, and I can select the table. And you can see that I have created an entry here, right? Then I will run this to show the read script that I'm using, which is this one. It's a different formatting from before, but almost the same query. Uh, I need to update this. Just a second. That's for the final thingy. So this is the query. The only difference from before is that I'm already giving the final final status on the update. So I'm not doing the two-phase thing about first moving to processing and then later okay or failed. If I move to processing here, it means that it will time out some eventually. It means a failed processing. Okay. And that's the only difference from before. Let's hope it works because I just changed some stuff there. This one. Let me see the outputs. Okay. Let's see here. Okay, it moved to okay. It is randomly selecting the status. I didn't tell it, but you can see here. Every time this script runs, it does a random between 0 and 2, and that's utilized to define the final status. I believe it's supposed to be a normal distribution. I'm not sure though. And of course, not relevant for me right now too. So these are the scripts that I will be using here. Let me truncate this. So no line, so 0 counts. This is the command I will use to benchmark the database. And I'm doing a mix of both scripts. So it will be writing, reading, and reading at the same time. Oh, just before that, I need to do something. Let me take the timeout stuff. This is the query that will update the lines that timed out, right? I need to have this in a production setting. You would have this in a cron job, PG cron, which is an extension, and it's like cron from Unix, but inside Postgres, and you just run some arbitrary SQL at
I saw people rebuilding
arbitrary.
that.
Wait.
I saw people rebuilding that, by the way. Like a whole glorified system that does the same thing.
Okay.
Single
Nice.
lane.
Nice. Yeah. So let's do this here. I will run this query. So 0 things to update. And now the magic of PSQL. I will be just running this each second. Because yes. Now let me take this benchmark commands, and I will do just 30 seconds, not 60. And keep in mind that my video is also consuming some CPU, so results might not be there. Well, it's of course not optimal because I'm doing everything in the same machine, right? Oh, sorry, that's not in PSQL. That's here. And then, oh, it's doing its stuff. Oh, uh, so it's running and reporting each second what's the transactions per second. And here we have the cron job doing the timeout of all the messages. We just need to wait for 30 seconds now.
We can hear your fan, by the way.
Yeah, yeah, we could for a moment hear the fan.
Oh, okay. So we got 1,400 transactions per second, which is not very good. But if I leave it for more time, it will keep going down because it's very poorly optimized right now, the table. So we can see this by doing this analyze,
And
explain how.
that's already more than most people need.
Yeah, sure. No, but that's the more entries you have in the queue, the worse it gets because the sex can't. So you can see here. I'm not an expert here too, but there is like I believe this is the part that fucks up this query. This comparing of two columns and this status comparing to. So we have 0 index here, and well, we can fix that by first I will truncate this to start fresh. It's not necessary, but I want to do it. Then I will alter the queue, and this is not the appropriate way to do that. That's just a hack. If I am doing inheritance, that's probably something that should be in the almighty father table for everything. So I'm adding a new column of type boolean. I'll call it can try again. It is a computed column, which is just the filters I showed you before. And I'm saying that it should be stored just like a normal column. It should write to the disk, right? Not computed every time. And then I do an index on these both fields, the created, the can try again, and the created at, which is needed for the ordering. So I just created this, and let's run this again. And I thought it would be more. Perhaps it's not using the. Okay, makes sense. I forgot something. I just created this field, right? Which is the field I should be using on the where clause, and I'm not using it. Now it should be better. Yeah, It's a lot better. And that's it. You can just watch the benchmark ends.
Indexing really works, huh? We went to
Yeah.
2000.
Yeah.
Oh yeah, oh boy.
And mind you, that's the database is running on my computer. I'm doing the benchmarking. The client side thing is also on this computer. I'm doing
Yes, yes,
lots
yes.
of stuff. That's by no means a real benchmark. It's just a toy example. We are not doing a very serious thing here. But that's it. We end up with 11,000 transactions per second, which would be quite a lot for, I would say, 80% of the companies. And I'm being generous. Most
I
people want.
have I have a question slash commentary. Uh, like it's kind of painful to see. Like Postgres, for example, doesn't have a lot of the stuff that comes cooked in when you have another vendor. Like SQL Server does have a queue, priority queues, and all of that stuff.
Yeah.
Uh, but I think the main thing that pains me on all of them is the language, right? Essentially. So just to give a background, I was reading this book and I was talking to Belani about it's called a guide to the SQL standard. So it's basically a book on CGDate and other people making a commentary over the SQL standard, right? Of course, the book is old. The SQL standard changed a lot, but it serves to show a lot of the design, right? The thinking that went into SQL. And there's this part on the update on views that got my attention. Belani even got complaining about it. Like it's like views on SQL, they suck, and it's a limitation by the language, right? So for example, you can't like the views, they don't allow update operations like on views. Like they're only allowable if the view consists of a simple uh, row and column subset, right?
Okay.
So so if you don't have, like, for example, you can't have a join, like, that's
Yeah.
just to say it, right? And that sucks, like because the whole point of views is to have the normalized uh relations, and then from that onwards you build a view that will be on display to decouple the domain, the model,
Yeah.
from the application that is targeting it, right? uh so in your question, in your concern now, Jean, doing this, like, I know, I think you are way more experienced than me in Postgres. I barely used like SQL, like the SQL variant that goes in Postgres. Uh, but in your experience, like, what are these problems that you feel like that Postgres gets lagged behind because of SQL,
Mm.
or if it's flavor, it's dialect, right? To say another way.
I think I'm well. For to be short, I don't know. I'm not sure. I'm not that experienced to know this, but I think some places they just say fuck it to the standard and I will do it my way and
I
it's
think
it
Oracle did that, right?
yeah. I
For
mean
example.
the systems can do it and it's okay. I mean, if
Uh,
the standard is not good, why should you follow it? If it's being
But I
the
think also there's a limit on what you can change, right? With the standard. Of course, you can change. Like, the ideal world would be that you can change all the machinery and then you end up with the same syntax, right? But then I'm gonna give a cliffhanger, and this is for my talk next week. I think the syntax also has its limitations, right? It also
Oh, yeah.
asserts a set of constraints that you can uh, express, or at least it influences greatly what you can express in the with it, right? At least it makes substantially harder. That's my point.
Okay, that's
Yeah.
fair.
So,
But I want to counter your question with another question, Magita. Do you know? Do you happen to know which vendor has the SQL that sucks less or not?
like, I'll give one example, okay? Like Postgres, PL. I mistake often like PL SQL, which
PL
is
SQL.
Oracle's, right? With Postgres, PG, PL SQL. Uh, but like for example, for loops, like they are not they're a thing that breaks the relational model, right?
Yes.
Essentially,
Yes.
uh, like they're incompatible with the idea of handling things as a relation because you basically
You have
are
statements now.
transiting over you're jumping over states, right? It's
Yeah.
not like, for example, when you have a programming in Prolog that you have every state if you don't have IO, right?
Mhm.
Expressed on a
It's not declarative in
exactly, yes.
summary.
Yes.
In summary,
Uh,
you leave the declarative word. So yeah.
yeah. So, for example, T-SQL, which is the SQL Server flavor, it doesn't have force for that reason. It does have cursors, which is cursed, but that's another thing.
But it's the same thing, just another
Yes,
name,
but
right?
the point, yeah, but my point is they purposely try to hide a few things, right? So, for example, it doesn't have lists as well, uh, for that reason, right? So you can't express a column as a list, but you can express as a table, like inside of another table. So it's still you're
Ooh.
denormalizing in that sense, right?
Yeah,
So
that sounds cursed. A table inside a table?
I mean,
Jesus.
it's a type, right? A table type. So
Okay.
it's semantically that's almost the same thing, right? So
I
that's
mean, if you take this to a more dynamic context, a table inside of a table is like a map inside of another map. It's slightly unusual because you can just splice the keys onto the top level, but you can certainly do it. I don't see why not.
Well, because if you
Whether
have a
that's a
table
good
in.
idea or not is a
well,
separate
I
question,
the
though.
No, but
problem
that's
here
the
is
thing.
that
That's what Magetta said. That sounds like doing the opposite of normalization.
yes, it is essentially,
Which
which
we
is
care.
Yeah.
fine.
I
Like
think we
which is
care.
like I mean, it's fine, right? If you're displaying data, it doesn't really matter, right? That's just that's the whole point. Like that's what I meant about the whole point of views, right? The point of views is that the data model should be expressed like in a relational way. It should be expressed relationally because that's basically how business rules they will be enforced, right? In this uh, scope of the world. Let's put it that way.
Yeah.
Uh, but that doesn't mean that, for example, if you have a application that uh, demands the data in a specific way that is not the same way as the other systems will, you're not going to enforce this way all the way up to the model. You just basically make a you can make changes on it and potentially denormalize on the view, so you can expose that area,
Yeah,
right?
no, you make separations between the real deal and the insanity. You can do
Yes,
whatever in
like
the other side. I don't
because
care.
I because that's the point, right? You at some point you will have to you may face a constraint right on the application,
Yeah.
and then it's very hard for example to maybe in some circumstances like one that I am right now to just rely on having the data like normalized. That alone I don't think uh, it would be like it would demand changes in the code as well, right, to
Yes.
adapt to this behavior.
Yes.
So that's mainly the problem.
Yes. So, any
But
more
man,
other
I
questions
don't
to the
know, like
John? Sorry, Magita. Go on.
it's just that you said about the question. I don't think I answered right. I don't know. I
No,
really don't.
no, but you said
I haven't
T-SQL.
used. No, I just said two things, right? But it still sucks. It's not.
Wait, we lost our audio.
Uh, oh, sorry.
Okay.
Can you hear me?
Now, yes. You just said.
Okay. It still sucks,
Oh
right?
yeah.
In the end.
That's
So
fair.
I think it's less worse when you have like the actual thing implemented correctly, but yeah, it's still not great.
It's still not great.
My
Yeah.
dream would be Prolog in our database. That would be awesome.
Let's make that happen, maybe. Who knows?
Actually, you would probably prefer Mercury because Prolog is dynamically typed, right?
Oh, that's fair.
Right, that's true.
But here's the deal: we don't have a syntax. We don't have a language, a query language for our stuff. Magenta can make it. So Magenta can have all the inspiration necessary.
All the inspiration.
Oh yeah. So any more questions to Jean before we finish?
I had one, but I forgot.
I don't have any more.
Yeah, I don't
So
recall.
if
Yeah,
we
nothing comes to mind.
okay, so great presentation, Jean, and I'm gonna finish the recording now. Do you want to say goodbye this time, Marinho, before I click?
Bye, future people.
Okay.